Welcome to The Explainer. Today, we're stepping right into a true crime-style forensic breakdown of a seriously severe post-compromise threat. We are looking at advanced persistent threats, or APTs, and honestly, how they achieve absolute total dominance over a target's communications. Because this isn't just about stolen passwords anymore. This is about deep, invisible, and terrifyingly persistent infiltration. Okay, let's dive into this. Imagine a scenario where a hacker gets into your account just once. Maybe it's through a zero-click exploit where you literally didn't even have to click a link. They're in. And from that exact moment on, resetting your password, it won't lock them out. No way. They've established this persistent, completely silent backdoor right inside your inbox, and it's operating entirely under the radar.
So, Section 1, the invisible inbox hijack, symptoms of a silent compromise.
Now, the symptoms of this silent compromise, they're kind of baffling at first. You might notice your physical hardware security keys, things like your YubiKeys just suddenly failing across multiple devices with this weird no credentials found error. Then, incoming emails silently vanish without a single trace. And when you actually try to reach out for help, say you're emailing Apple product security, those support channels are mysteriously intercepted and blocked. To understand why this happens, we have to look at the forensic evidence. These system logs actually confirm a root-level compromise. We see this persistent unknown process, identified here as process ID 178, just hijacking critical network services. This isn't a glitch, folks. It's an attacker who basically owns the device at this point. The streaming log here is reporting overwhelming disk write activity, over a gigabyte of data, actively being packaged up to be shipped off the device.
So, what's the end game here? The primary goals behind this infiltration are highly targeted. Attackers want data exfiltration, basically automatically forwarding any emails that contain juicy keywords like invoice or password reset. They also want operational hiding. That means they set up systems to silently delete any security alerts you might receive so you stay in the dark. And finally, impersonation. They'll deploy nested rules to literally reply to your existing email threads with fraudulent banking details. And astonishingly, over 80% of compromised accounts actually retain these malicious rules even after the victim goes in and resets their credentials.
Moving on to Section 2, Anatomy of the Attack. Weaponizing benign features. Let's look at how they pull this off, because attackers don't always need to invent fancy new malware to hurt you. Instead, they just weaponize the everyday, totally benign features we rely on to organize our digital lives. The main weapon of choice here is the Mailbox rule, or a Sieve filter. Now, normally this is just a legitimate OS-level or server-side automation tool you'd use to sort your mail into folders, but attackers weaponize it to instantly and persistently intercept your communications. And what's truly alarming is the speed. In observed incidents, attackers establish these malicious rules within 5 to 60 seconds of gaining initial access to an account. I mean, that's incredibly fast.
And this brilliantly illustrates how widespread and effective this tactic is among top-tier threat actors. We see state-sponsored groups using these exact rules for high-stakes espionage all the time. For instance, APT-28 out of Russia targets defense contractors using Office 365 rules. Then you have Kim Soo-ki from North Korea intercepting cryptocurrency password resets using catch-all forwarding rules. And Muddy Water out of Iran leverages them for internal phishing amplification. They basically compromise just one employee's inbox to automatically harvest and weaponize HR emails against the entire rest of the company.
All right, Section 3, Evasion and Stealth Tactics. Hiding in plain sight.
Now, these attackers, they don't just set up a forwarding rule and cross their fingers, hoping you won't notice. They use highly sophisticated stealth techniques to hide right in plain sight and actively subvert your attempts to find them. Let's look at a really clever technique called Inboxfuscation. To evade standard keyword searches, attackers use homoglyph attacks. This means they use characters that look absolutely identical to human eyes, but are completely different to computers. So a rule targeting emails from Apple is written with a Cyrillic A. That makes the malicious rule literally invisible to your standard security audits or UI searches. But wait, the evasion gets even deeper. Attackers utilize time-bombed rules that only activate at, say, 2 a.m. while the victim is fast asleep, and then neatly deactivate before business hours start. They use cascading delegation to bypass your data loss prevention tools. They'll even mark intercepted emails as read and instantly archive them just to stop your phone from getting push notifications. And most aggressively of all, they deploy diagnostic suppression. Forensic logs actually show widespread failures when the system tries to run basic utilities like uptime or power metrics, simply because the malware actively blocks those processes from running to prevent its own detection. This particular log file shows just how deep this system interference really goes. It highlights clear evidence of a local man-in-the-middle attack. The malware on the device actively intercepts outgoing secure TLS traffic. That's the standard encryption that usually keeps your web data safe. When the system tries to securely connect to Apple's update servers, the malware just presents a fake certificate. Attackers also use this anti-forensic trick called time stomping, where they manipulate the system clock to ensure their malicious activities are logged in a past or future window that investigators are highly unlikely to even check. Let's hit Section 4, Exploiting Apple and Proton, a forensic platform deep dive. Let's look at how this exact attack manifests differently across platforms, really exploiting their unique architectures. On Apple devices, the seamless ecosystem itself actually becomes the weapon. Attackers target a specific file called syncedrules.plst on macOS. They inject malicious shell scripts directly into the rules action payload. And here's the kicker. Because of iCloud Sync, a rule created on a compromised Mac instantly syncs to and infects the victim's iPhone and iPad. It is an incredibly efficient cross-device persistence mechanism. Now, what's really interesting about this slide is how this attack adapts to a secure end-to-end encrypted platform like Proton Mail. Because the email bodies are fully encrypted, attackers can't easily scan them locally. So instead, they exploit the platform's Sieve scripting language, which is just a feature designed for custom filtering. These scripts run on Proton's servers, targeting the email headers like subject and sender, long before the client ever even decrypts the message. In one really well-documented case, forensic investigators found a hidden Sieve script with a devastatingly simple line of code. They noted, and I quote, "The filter included a reject statement placed outside any conditional logic, which effectively halted all email processing." The impact of this is just absolute. Incoming emails aren't just hidden or moved to the trash folder. They are outright rejected at the server level. They never, ever even reach the inbox. Which brings us to Section 5, Reversing the Malicious Rules, Taking Back Control. We've seen exactly how complex the threat is, so let's transition into the actionable solution phase and figure out how to take back control of a compromised account. For Apple Mail cleanup, you really can't just rely on the standard preferences menu. First, you need to check the iCloud Web UI for any foreign script rules. Now, if the UI crashes, which attackers often design it to do, by the way, you have to use the macOS terminal. You'll navigate over to the Mail data directory and manually delete or backup that synced rules plist file. Finally, you have to meticulously comb through the application scripts folder and permanently trash any unrecognized Apple script or shell payloads the attacker might have left behind. For Proton Mail, the cleanup requires navigating the actual web application settings, mostly because mobile apps might not display the full Sieve code. First, you need to disable any unrecognized custom filters. Next, you have to meticulously review your spam, block, and allow lists. A super common tactic here is for attackers to place official security addresses, like Proton's own support emails, straight onto your block list so you literally never learn about the breach. Finally, go check your vacation or auto-reply settings for manipulated messages that are designed to mislead your contacts. So the crucial point is this: never, ever assume the attack is over just because you found and deleted one rule. Advanced attackers almost always set up a watchdog rule. This is a secondary, deeply hidden rule looking specifically for emails containing words like investigation, breach, or security. If you start emailing your IT support team to fix the problem, this rule immediately forwards your communications straight to the attacker, alerting them that you're onto them. Which brings us to our final question: is your inbox truly secure? It is so easy to assume everything is fine when it's quiet, but silence is exactly what an inbox hijack relies on to survive. So here's a challenge for you. Right now, send yourself a test email from an external, clean account with a subject line security alert. Does it arrive normally, or does it mysteriously vanish? Understanding these forensic realities is the very first step in defending against them. Thanks for joining me on this explainer, and definitely stay vigilant out there.